Hello, pre-algebra friends. Thank you for watching 5.4 multiplying fractions. Some of these problems I've already worked, and I'll just talk you through them, and then I've got some that I'll be working with you on some of the pages as well. So we've been adding and subtracting fractions, both with like denominators and unlike denominators. As you might imagine, what's left to do is multiplying and dividing. So this section is on multiplying fractions. There is one thing I really am going to stress, and I'm going to make some problems such that you really need to do the simplifying before you multiply. So you are looking for common factors, numerator and denominator, before you even think about doing the actual multiplication straight across numerator and denominator. Again, I want to remind you, you do not use common denominators when you are multiplying or dividing fractions. That's only for adding and subtracting. It's really easy to kind of get in the mode of just finding the LCD and doing that when you're multiplying, and you're making your problem much bigger, much larger, and much harder to get the correct answer. So let's go through a few of these. Reminding, these are just simplifying these fractions. We've been doing this in all of chapter 4 and actually early chapter 5, so this should not look new to you. 28 I can think of as 4 times 7. I can think of 40 as 4 times 10. The 4's cancel. 7 over 10 is my answer. They're relatively prime, so I am simplified to the most possible way I can be. Number 2 has got like bases. A is our base. When we're dividing like bases, we subtract the exponents. So A, 4 minus 2 is 2. The 2 that are left over are in the numerator. So my answer is a squared, or you could write it a squared over 1 if you preferred. Number 3, common factor. 5 times 3, 5 times 5. The 5's cancel. We're left with 3/5. And one more with variables. 18, 6 times 3. 24, 6 times 4. And m to the 5th minus m over m squared. 5 minus 2 is 3, so 3m cubed over 4 is our answer. So notice we're not stretching these m's out and canceling them. We're just doing the rules of exponents, which say we subtract and move along. All right, first page, done. So we're going to practice finding the product of some fractions. We're going to rewrite the problem with one fraction bar. We're going to reduce, and then when everything that's reduced that can be reduced is multiplied, we will multiply then. Again, no common denominators. So we're going to rewrite with one fraction bar. Here's my single fraction bar. I see a 7 up here and a 21 down here, which I know I can make that 21 7 times 3. So I'm going to go ahead and write it like this. I see a 4 and a 10. I know a 2 will go into both of those, so I'm going to rewrite 4 as 2 times 2 and 10 as 2 times 5. Whoa, I got too close to the 7. Looks like 57. So let me go fix that. So 2 times 5, and then that was a 7 times 3. Now I'm going to cancel lightly so I don't wipe out anybody else. And I'm going to put it back together. 2 is the numerator, 15 is the denominator. That's much simpler than multiplying 4 times 7 and getting 28 over 210 and then have to reduce it all the way down. So we're going to simplify before we multiply. All right, we need to change this mixed number into an improper fraction. 4 times 4 is 16, plus 3 more is 19 over 4 times 63 over the ghostly 1. Make a single fraction bar, 19, he's prime. I don't see anything I can do about him. 63, 9 times 7, that doesn't help very much with the 4. So unfortunately, in this instance, we've got a large multiplication to do. So if you hop on your calculator, which I don't seem to have one on me, 63 times 19, I'll grab a calculator. Let's see, so 63 times 19 is 1197. So this is 1197 over 4, and that's your answer. You're done. You don't have to change it into a mixed number for me. Okay, let's keep going. We'll throw some variables in here. This is a negative times a positive. I write my sign down, circle it, and forget about it. Single fraction bar. We always want to write our numbers in front of our variables. So I see 12, and I see a 3 down here. So that's going to work nicely. I can think of 12 as 4 times 3. There's the m. And in the denominator, I have 3 times 5. The 3's will cancel. Put it back together again. Minus 4m over 5 is your answer. Let's look at this guy. Okay, single fraction bar. The 5's going to come before. I'm going to use the rule of exponents. If we're multiplying like bases, we add the exponents. 5 and to the 5th. In the denominator, this 10 I can think of as 5 times 2 times the 9 that's there. No need to split the 9 up into 3 times 3 because there's nothing in the numerator that's going to cancel. So I'm just going to leave them alone. Cancel out the 5's and put it back together again. N to the 5th power over 18 is my answer. Are you getting it? Getting the hang of it? Let's do a couple more together. So I've got a negative times a negative. A negative times a negative is a positive. There's my sign. Circle it and forget about it. You're done with the sign. Now I've got a 2 and a 3, so I'm going to write the numbers first, and then I'm going to write this x to the 4th because there's the ghostly 1 exponent. And the rule says if you're multiplying like bases, you add the exponents. In the denominator, I see a 9, which is going to help out with that 3 on top. So I'll rewrite the 9 3 times 3, and I'll rewrite the 4 also. So we've got some stuff that'll cancel nicely. This 3, that 2, and I'm going to put it back together again. My product's positive, so I don't have to write a sign at all. X to the 4th is the numerator, and 6 is the denominator, 3 times 2. Let's keep going. These are 2 positive fractions, so I don't even have to worry about the sign. It's positive. Single fraction bar, 3 times 2. Numbers come first. Z to the 8th. Add the exponents. 25, I could split them up into 5 times 5, but why? There's nothing up here that'll help me with, so I'm just going to write the 25 right here. But the 15, I will make 3 times 5 because those 3's will then cancel. And now I put it back together again. 2 z to the 8th over 125. And that's the answer. Okay, a couple more. All right, here's a page that I've done some already. Here come the big dogs. These problems, these fractions are big. There is no way you want to multiply 18 times 49 times 16. That's a big number. Even if you have a calculator, it doesn't matter. You're going to end up with a huge numerator, a huge denominator, and then you have to simplify it because we always have to write our answers simplified. So I'm going to look at 18, and I'm going to look down here and say, what do I see that maybe this 18 is going to be able to cancel with? Now, I do know that 18 is 9 times 2, and maybe down here I've got a 9 times 7 for 63, or a 9 times 8 for 72. So I'm going to go ahead and make the 18 9 times 2. 49, there's not much you can do with it except 7 times 7. And 16, I'm going to write as 8 times 2. And then I can break apart my denominator. Here's my 35, 7 times 5. Here's my 72, 9 times 8. Here's my 63, 9 times 7. So I'm going to cancel now what I can and see what I got left. So I've got a 9. That'll cancel. 9 here, 9 there. I've got a 7 and a 7. Another 7, and this 7 over here, and the 8 will cancel. I don't see anything else that I can cancel. I've got a 5, and all I have is 2 2's left. I've got a 9, 2 2's. I'm done. I got to put it back together. 2 times 2 is 4, and 9 times 5 is 45. And that didn't take any time at all, and we had no numbers bigger than a 9 in our numerator and denominator. I want you guys to do number 8 on your own. You can either pause the video now and work it now, or do it at the end. Okay, remember, of means multiply, especially when you're dealing with fractions. It makes a lot of sense. If I ask you what is 1/2 of 3/4, replace the word of with the multiplication sign. Single fraction bar. I have a 1 and I have a 3. I have a 2 and I have a 4. Nothing cancels. So I'm done. 1 times 3 is 3. 2 times 4 is 8. Okay, let's try this one. 2/5 of 1/4. Replace the word of with the multiplication sign. 2/5 and 1/4. Single fraction bar. 2 times 1 and 5. And I'm going to break this 4 up into 2 times 2 since I've got a 2 up here that'll cancel. Put it back together again and you end up with 1/10 being your final product. Our friends, area and perimeter are back. This looks complicated. It's not. It just takes a little bit of time. Here's your rectangle. I hope you have this. If you don't have this one drawn on your notes, you can draw. Oh, yeah, you have it. I see. Okay. Area, length times width. Both our length and our width are fractions. So you're going to multiply. Single fraction bar. 9 and 5 are in the numerator. 10, I can make 5 times 2. I'm going to leave the 8 alone because he doesn't have anything in the numerator to cancel with. Put it back together again, and you end up with 9/16, and of course it's square units for any area problem. The perimeter is a little bit longer. 2 lengths plus 2 widths. The length is 9/10, and the width is 5/8. I did my substitutions in blue. These are multiplying 2 fractions. I'm going to use a single fraction bar for both of those. I'm going to split this 10 into 2 times 5 so I can cancel the 2 that's there. I'm going to cancel the 2 that's here with the 8 being 4 times 2. And now I end up with an addition problem of 2 fractions that do not have a common denominator. So now because I'm doing addition, I'm going to go find a common denominator, which happens to be 20. I'm going to rewrite the numerators with the correct number to make them 20ths. Single fraction bar. Add the 36 and the 25/20, and your answer for the perimeter is 61/20 units. This may be one you might want to work on your own. Kind of cover this up with a sheet of paper and see if you can do this on your own. Couple more. Oh, yes, I have some problems for you to do, as a matter of fact. So 12 and 13 are area and perimeter. I want you to work both the area and the perimeter, just like I did in the other 2 examples. I'll do number 13. I'll do the triangle one because we haven't done a triangle area in a while. So the area of the triangle is 1/2 base times height. 1/2, sub in the base, which I'm going to make an improper fraction. So that's 43/10. And the height is this guy, and he is 10/3. So I've got 3 factors I'm multiplying together. I'm going to do a single fraction bar. 43 is a prime number. I can't do too much with 43. But 10 I can make, well, actually, I'm not going to make him 5 times 2 because, look, there's a 10 in the numerator and a 10 in the denominator. They'll cancel nicely. I just said I wasn't going to make that 5 times 2. And I won't. So the 10s cancel, and we're about done. Don't make the mistake of thinking this 3 cancels with this 3. That's 43, and this is 3. If you spread your numbers out, you won't make that mistake. If you cram your numbers together, you might possibly think that you could lop that guy off. So this becomes 43/6, and it's square units. I'll leave the perimeter to you. You're just adding the sides. I've got a few more problems I want you to work, just these 14 and 15. Remember your order of operations. Remember your signs. Remember your common denominators when you're adding. And remember to use single fraction bars and cancel first when you're multiplying. So this will about end this video, and we'll practice more of this when I see you in class next week. Bye-bye.